Here's number 1 from the mean value theorem worksheet from section 4.2, but we do have this worksheet with some other problems on it. So I want to check f of x, and remember the directions up at the top of the worksheet tell you for the following functions determine whether the mean value theorem applies on the given closed interval. If it applies, state why it applies, and find all values of c that satisfy the mean value theorem. So first of all, we want to check to see is it continuous on this closed interval. Well, if we look at this function, it might be a little vague of what's going on. We know we have a problem when x is equal to 0, but what about all the other points? Well, if we kind of rewrite this, negative 4 times 1 over x plus 5, this basically is just swoosh. It's one of our parent functions, but it's going to be just shifted up 5, not left or right, so that's important. And it's going to, be kind of flipped, and it's going to have a size change, but otherwise, it's basically centered at 0. So when x is 0, this is when it's undefined. We have an infinite discontinuity. So it's not continuous there, but this is not in our interval. Our interval is from 1 to 4, so we're okay. So we can say this is continuous. Continuous, OUS, continuous. On the closed interval. Okay. On the closed interval. Now what about differentiability on the open interval? Well, let's see what the derivative looks like. F prime of x equals, and I'll just use this form over here. That's the derivative of 5 is 0. And I got negative, well, right over here I can say the derivative of 5 is 0. I can do it like that. This is probably a little bit better. So the derivative of the first term is going to be what? Well, negative 4. And what's the derivative of 1 over x? Well, we have our formula for that. One of the ones we derived, negative 1 over x squared. And the derivative of 5 is 0. So f prime of x will equal positive 4 over x squared. So this is okay, except now this looks like it's, or 4 times 1 over x squared. And this is just like double swoosh. So there we go, double swoosh. And the only problem where double swoosh is not continuous, or any other issues like that, would be when x is equal to 0. And again, 0 is not in the open interval, so we can say f of x is differentiable, so f of x is differentiable. Differentiable is differentiable on the open interval 1, 4. Like I said, the only problem would be at 0, and that's not in the open interval, so we're okay. So therefore we know by the mean value theorem, so we use these abbreviations, and that's fine. So therefore there exists, that's the backwards capital E means there exists some c belonging to the open interval 1, 4, such that f prime of c equals f of b minus f of a all over b minus a. Okay, and there's our a and b. Now we're going to use the closed interval for the average rate of change. So f prime of c, now our derivative was 4 over x squared, so we'd say 4 over c squared equals, and then f of b, if I put 1 in here, all right, I can do this over here, I guess, f of 4, excuse me, b. That equals 5 minus 4 over 4, which is equal to 5 minus 1, which is 4. That's going to be 4 minus, and then if I put a in here, which is going to be the 1, f of 1, I get 5 minus 4 over 1, which is 5 minus 4, which is 1, all over b, which is 4, minus 1. Okay? And that's just 1, so we have 4 over c squared equals 1. So if I multiply both sides by c squared, I get 4 equals c squared. So c equals plus or minus the square root of 4, which is just plus or minus 2. Now, our interval is from 1 to 4, and we're really just interested in the open interval. So 2 belongs to the open interval, 1, 4. Not negative 2, so that's what we're going to do. So that's what we're interested in. So c would equal 2, and that's the value of c that satisfies the mean value theorem. Okay. Let's take a look at number 2. And f of x equals x squared minus 1 all over x minus 2, and we're on this closed interval. On the closed interval, -1 to 3. And when x, we know we have a vertical asymptote at x equals 2. And 2 is in the interval, so this is not continuous. So f of x is not continuous on the closed interval. Because at x equals 2, we have a vertical asymptote. So f is not continuous on the closed interval, -1 to 3, comma, so therefore the mean value theorem does not apply. So that's a nice, easy one. Okay? But you do have to state why it does not apply, so make sure you write that down. And remember, it has to be continuous on the closed interval and differentiable on the open interval.